కుదిరితే
ఓకే
20 బిట్స్ ఏమన్నా.
ఓకే
ఆల్కహాల్స్ ఈథర్స్ ఒకటి చేయండి.
ఓకే
కార్బన్స్ రెండు కూడా పెద్దవి కదా,
అవును
దాదాపు 2 క్వశ్చన్స్ వస్తున్నాయి మనకి.
అవును
సో దీని మీద ఒక పేపర్, దాని మీద ఒక 20 బిట్స్ ఏమన్నా టైం తీసుకొని చేస్తే, టైం ఉంటే కదా, టైం తీసుకొని చేస్తే పిల్లలు
టైం తీసుకొని చేయాలి సార్. ఎర్లీ మార్నింగ్ అయితే టైం దొరుకుతుందండి, మంచిగా అనిపిస్తుంది.
కొంచెం మంచిగా ఉంటుంది. ఈ పిల్లలకి ఇవ్వట్లేదు చాలా మంది కదా.
ఇలా అంటే ఎగ్జామ్ స్టార్ట్ అయినా
గ్రూప్ లో చూస్తే 970 స్టూడెంట్స్ అన్న వాట్సాప్ గ్రూప్ లో. తర్వాత వీడియో కొందరు చూస్తానులే, బట్ క్లాసెస్ కి అది ఇంతమంది ఎందుకు జాయిన్ అయ్యాలో తెలియదు. ఓకే చూద్దాం, ఇదివరకు బెనిఫిట్ అయితే చాలు మనకి.
అవునండి.
స్టార్ట్ చేస్తారా మరి?
ఓకే, అంటే ఫాలో అవుతురా? ఫీడ్బ్యాక్ ఉంటుందా? ఫీడ్బ్యాక్ కూడా పెట్టాలి, ఏమన్నా ఇంప్రూవ్మెంట్
ఫామ్ పెట్టడా? ఫీడ్బ్యాక్ ఫామ్ పెట్టాలి.
అట్లా కామన్ ఒకటి తయారు చేసి పెడితే మనము నెక్స్ట్ టైం ఎంగేజ్ చేద్దామని. అండ్ థ్యాంక్ యూ అన్న ఫర్ గివింగ్ మీ దిస్ ఆపర్చునిటీ. ఓకే, ఎందుకంటే
చూడాలి పిల్లలు ఎక్కువ మంది బెనిఫిట్ అయితే మనకి హ్యాపీగా అనిపిస్తుంది. ఇంకా ఇంత
సబ్జెక్ట్ అప్డేట్ అయిపోయింది.
పడుకునేదాకా వీళ్ళ గురించే, పొద్దున్న లేవగానే వీళ్ళ గురించే చూస్తున్నాం. అది కూడా అదే ఎఫర్ట్ పెడితే మనకి మంచి రిజల్ట్ వస్తే బాగుంటుంది. రైట్ భయ్యా, మరి మళ్ళీ హోస్ట్ చేయాలి, మరి హోస్ట్ చేసి నేను లీవ్ అవుతాను. రైట్ భయ్యా, థ్యాంక్ యూ. సో ఫైనల్లీ కెన్ ఎండ్ ద మీటింగ్. Where is it? Make host. Okay, Bhaiya, now you are the host.
Okay, very good morning, students. Last classes we had seen about alcohols and ethers. Okay, carbonyl compounds are also very important area of this organic chemistry, where you can prepare any compound without knowing or without learning this carbonyl compound. What are carbonyl compounds? Can anyone tell me? They contain, what is the main functional group in this one? What is the main functional group in carbonyl compounds?
Aldehydes, ketones.
Okay, C double bond O is the main functional group. Okay, C double bond O is the main functional group. How many types of carbonyl compounds are there? There are 2 types. One is aldehyde, another one is ketone. Okay, another one is ketone is the main functional group here. Then slide is not changing. Can you see the screen? Hello students, screen కనబడుతుందా?
Yes sir.
Okay. Okay, carbonyl compounds, pi electron cloud is displaced towards more electronegative oxygen atom. Okay, for example, if there is an oxygen atom, it is okay, that is, it is pi electron cloud is displaced more towards electronegative atom. ఒకసారి ఒక క్వశ్చన్ వచ్చింది ఏంటంటే ఇక్కడ విచ్ ఈజ్ మోర్ స్ట్రాంగర్ ఇట్లా ఇస్తాడు. సి డబుల్ బాండ్ ఓ, సి డబుల్ బాండ్ సి అండ్ సి ట్రిపుల్ బాండ్ సి, విచ్ ఈజ్ మోర్ స్ట్రాంగర్? హలో స్టూడెంట్స్, సి ట్రిపుల్ బాండ్ సి కూడా ఇచ్చిండు అనుకోండి, విచ్ ఈజ్ మోర్ స్ట్రాంగర్ చెప్పండి? C triple bond C is more stronger. Why? Because it is, what is the bond here? Triple bond. Okay, please respond. ఈ రెండు కూడా ఇచ్చినప్పుడు ఓన్లీ ఈ రెండే ఇచ్చిండు అనుకోండి, విచ్ ఈజ్ మోర్ స్ట్రాంగర్? డౌట్ వస్తుంది మనకు. సి డబుల్ బాండ్ ఓనా, సి డబుల్ బాండ్ సీనా? జనరల్ గా మనం ఏమనుకుంటాం, ఇది పోలార్ కాబట్టి ఎలక్ట్రాన్స్, ఓకే, ఇట్ ఈస్ పార్షియల్లీ పాజిటివ్ చార్జ్ కాబట్టి ఇది వీక్ అనుకుంటాం, పోలార్ కదా. Okay, but it is more stronger because of the attraction. Electric, that is attraction is there. Opposite charges attract, therefore it is more stronger bond. Okay, this is one of the important point you have to remember in this slide. Any doubt here? Please respond. Ardhamaitunda? Hello students. Okay, shall I move further? How to prepare alcohols? Alcohols are prepared by the oxidation of aldehydes are oxidized to acetic acid and RCOOH. Aldehyde is okay, that is, we can oxidize these alcohols are converted. See here, these are converted to give, that is, aldehydes by using potassium dichromate in the presence of acid. Acidic medium, if you convert, they are forming aldehydes. The green color indicates stage of completion. Once the green colored chromium is formed, it shows that it is prepared, that is, aldehyde is completely prepared. Orange color is converted into green color. What is a reagent? My dear students, yesterday I told you that you have to remember the reagents. Okay, that is potassium dichromate in the presence of acid is the reagent that is used here. Okay, there are some other reagents. What are those? Not only potassium dichromate, we can use even potassium permanganate also. For example, potassium permanganate if used, what happens if potassium permanganate is used? They are converted into acids. Carboxylic acids are prepared, are formed. Okay, manganese 7. KMnO4 contains manganese plus 7 is there. It converts into, that is MnO, manganese oxide. Having solution, how many electrons are transferred here? 5 electrons are transferred. You have to remember these electrons also. Sometimes in neutral solution, only 3 electrons are transferred. Okay, MnO2 can oxidize. These are the different metal oxides that are acting as oxidizing agents. Hello students, please try to understand all this. Okay, but what happens is when KMnO4 is used as a, that is, reagent, what is the main drawback? The drawback is, what happens here? They are converted into aldehydes in the first stage. Immediately they are converted into carboxylic acids. Therefore, what we have to do is we have to avoid the second reaction. Yesterday I told you that this dichromate, potassium dichromate, is converted into mild reagent, pyridinium chlorochromate. This is the structure of pyridinium chlorochromate. Okay, that is in anhydrous media such as CHCl2 oxidizes primary alcohols to aldehydes and alcohols to ketones. Alcohols are converted into ketones. Secondary alcohols are converted into ketones. Primary alcohols are converted into aldehydes. My dear students, what is the reagent that is used to produce aldehydes only? If you want to produce aldehydes only, we have to use PDC, pyridinium dichromate and pyridinium chlorochromate. These are the reagents. Yesterday we had seen in the last alcohols also about this oxidation known as Opanier oxidation. Aluminium tertiary butoxide or aluminium that is butoxide, tertiary butyl group. It is a trivalent. It is giving this, that is, alcohol is converted. This is the alcohol we are using. It is converted into aldehyde again. Okay, it is converted into aldehyde. Are you getting my point? What is the reagent? Whenever I told you that whenever aluminium isopropoxide, okay, or otherwise called as tertiary butoxide, tertiary butoxide. The aluminium tertiary butoxide is used as the reagent, then what you have to do is, it is nothing but Opanier oxidation. It is called as Opanier oxidation. Okay, yesterday we had seen even the mechanism of the reagent also. Okay, it is known as Opanier oxidation. Actually, it is okay, that is hydride transfer will takes place here. hydride is going to be shifted. Hydride shift takes place. If you go through the earlier class, open air oxidation, the reverse of open air oxidation is known as, what is it known as? Merwin-Pondorf-Verley reduction.
MPV
it is known as
reduction.
Merwin-Pondorf-Verley reduction, MPV reduction. Okay, that is about oxidation of alcohols. Aldehydes can be prepared by reduction of acid chlorides. Reduction, by using reduction also we can prepare acid chlorides. Okay, the reagent in open air oxidation is different actually. In the next class I will discuss about the mechanism. Only aldehydes can be prepared by the reduction of acid chlorides with hydrogen using palladium catalyst. This is known as Rosenmund reduction. Barium sulfate acts as a poison for palladium catalyst and prevents. Okay, this is the reaction. This is known as acid chloride in the presence of palladium, barium sulfate, hydrogen. Okay, that is addition of hydrogen is known as reduction. Okay, that is acid chloride is reduced here. It is known as Rosenmund reduction. We can prepare only aldehydes from this one. Okay, we can prepare only aldehydes from this reaction. Okay, what is this one? What is happening? What is the use of barium sulfate? Barium sulfate acts as a poison for palladium catalyst and prevents reduction of aldehydes into alcohols. We know that last class I told you that there is a sequence. For example, if we want to prepare, generally alcohols are there. They are converted into aldehydes or carbonyl compounds on oxidation, and which are converted into, they are converted into COOH, that is carboxylic acid. Our acid chloride is nothing but the derivative of carboxylic acid. Okay, it is a derivative of carboxylic acid only. We are removing OH, and if you want to go back in this reaction, what is the step that is required? Known as reduction. Forward means oxidation. Forward step means oxidation. Okay, the reverse step is reduction reaction. Reduction. This step is oxidation step. Okay, this is known as Rosenmund reduction. What is the metal used here? Palladium. What is the use of barium sulfate? It poisons this palladium. Okay, that is the main purpose of this one. There are some other reactions. Acid chloride also can be reduced to aldehydes. In the last class, I told that we had discussed that lithium aluminium hydride is one of the reagent. Lithium aluminium hydride is a reagent that is used. Okay, lithium aluminium hydride. What are we doing? We are converting into mild, that is, we are removing these 4 hydrogens and keeping only 1 hydrogen. Okay, that is, we are taking sterically hindered one so that it will not react. Generally, there are 4 hydrogens. To make it mild, we know that lithium aluminium hydride is very strong reducing agent. We are making it mild, koncham weak ga chestunnam danni, so that it is converted or reduced only up to this stage. Further stage reduction, further stage into the alcohol side. Further alcohols cannot be prepared. That is why it is reduced. Okay, alcohols cannot be prepared by this one. Okay, that is esters are also reduced. Esters are reduced to sodium aluminium hydride to aldehyde, and dipol H, diisobutyl aluminium hydride is also one of the reagent that is used to reduce esters. Okay, dipol H. Please remember all this reducing agents in this organic chemistry. What are we doing? We are converting lithium aluminium hydride into mild, that is weak reducing agent. Dipol H is one of the weak reducing agent. Sodium aluminium hydride is a weak reducing agent. Okay, lithium that is a tri-tertiary butyl lithium aluminium hydride is also a weak reducing agent. Don't think that weak means it is not useless. It is useful. Okay, that is very important, my dear students. Then hydrolysis of gem halides. Gem means, what do you mean by gem? If one of the carbon is having two chlorine atoms, two halogen atoms, it is called as gem. Okay, if what are we doing here? We are converting this chlorines to OH. We are substituting chlorine with OH minus. Okay, it is nothing but nucleophilic substitution reaction. Nucleophilic substitution reaction. Where OH is, what are we doing here? We are converting this one into OH. Okay, therefore here OH group is formed, and here we are converting Cl to OH. Then what happens? Immediately gem diols will lose one water molecule. Then what will be remained? CH3, CH2, CHO is remained. Okay, that is aldehyde is prepared like this. Okay, these are called as gem dihalides. Gem dihalides, please remember, it is useful in other reactions also. These two chlorines are easily substituted by OH. Okay, they are substituted by OH, and finally dehydration takes place rapidly, and it is converted into ketones. Okay, secondary gem halides are converted into ketones. Primary gem dihalides are converted into aldehydes. Okay, then hydration of alkynes. If you see this reaction, this is very important, my dear students. Whenever you come across alkynes, they are hydrated. Okay, that is what is the hydration? We have to add H to one and OH to another one. When it is added, what happens? One of the triple bond is converted into double bond. Okay, that is which on tautomerization or in the presence of acid, it is giving ketone. Okay, that is ketone is formed with this alkynes. Formation of enol is formed. Enol. Okay, this enol is formed. This enol now that is tautomerizes to give methyl ketone. Okay, whereas if you want to prepare aldehydes, you have to take acetylene. Why? Because two carbons are there. Okay, very important. What is the reagent used? HgSO4, H2SO4 reagent, mercuric sulfate, HgSO4. Whenever you come across this reagent, generally it is meant for preparing aldehydes and ketones from alkynes. HgSO4 and H2SO4 are used here. H2SO4 are used as a reagent. What is the use of mercuric ion? Generally, it is electron rich. How many electrons are there here? There are 3 bonds are there. Triple bond is there. This triple bond, it is how many electrons? Pi electrons are there? Can anybody tell me? Any pi electrons unnai ikkada? Any electrons unnai? 3 means 6 electrons, out of which 4 are pi electrons. Okay, it is electron rich. మనం ఏం చేస్తున్నాం? We are adding OH minus, nucleophile is added. Okay, OH minus is added. Okay, that is OH minus is added here, and it is a nucleophile. Electron rich to nucleophile kalptama. We cannot add. The nucleophile cannot be added to this one. Therefore, enol is formed. Enol. దానికి ఏం చేయాలి మనం? ఎలక్ట్రాన్ షుడ్ బి డెన్సిటీ షుడ్ బి డిక్రీస్డ్. దాని కొరకు ఇట్ ఈస్ బైండెడ్ టు Hg+2. Hg+2 కు బైండ్ చేస్తాం. It is binded to Hg+2. As a result, the electron density is decreased. For that sake, Hg+2 ion is used. Hg+2 ఎందుకు అవసరము అంటే ఇక్కడ ఎలక్ట్రాన్ల సాంద్రతను తగ్గించడానికి అవసరము. అది గుర్తుంచుకోవాలి. ఓకే. What happens here? Alkynes are hydrolyzed to form carbonyl compounds. Acetylene, 2 carbon containing acetylene is converted into aldehyde. 3 carbon containing is converted into ketone like this. Then hydroboration. We had discussed in alcohols this one also. Hydroboration means we had used diborane. Okay, diborane is used and it is again BH2 is added to one. This triple bond containing alkyne is reacted here. BH3 is added. As a result, what happens here? Trialkyl borane, which followed by oxidation gives enol. Tautomerizes to give ketone. My dear students, we have discussed this reaction in alcohols, but in alcohols, what we have taken? We have taken double bond. When double bond is taken, it converts into single bond here, and only primary alcohol or secondary alcohols are prepared. Whereas if you take triple bond, alkynes are converted into aldehydes and ketones. This is called as hydroboration reaction. Okay, that is vinyl borane is the intermediate. Vinyl borane is the intermediate formed in this reaction. If you want to reduce that is, if you want to prepare sterically hindered alkyl borane reagent, can be used to convert them into aldehyde. Why? Because there is every chance that they are converted into, that is further reduced. Why? Because borane, there are 3 alkyl groups, whereas if you take sterically hindered borane, already we are having this cyamyl borane, dicyamyl borane. It is converted into aldehyde. This is called as sterically hindered borane is used here. Nitriles, HCN, they are converted into aldehydes, that is by using Grignard reagent. RMGX is attacked here, R, that is R minus, that is nucleophilic addition takes place. It is nothing but again aldehydes are formed. From nitriles, nitriles means cyano compound, hydrogen cyanide. For example, if you take, you prepare aldehyde, if you take RCN, alkyl cyanide will give ketones. From acid chlorides and esters. Okay, that is from esters, if you take RMGX is added, what happens in this ester? R, that is alkyl group, is added to alkyl group is added here. This is added to this carbonyl carbon, which, okay, that is converted into oxide, alkoxide, which rearranges, and this ethoxy group is lost. It is called a leaving group, best leaving group, and it is converted into aldehyde. If you take other esters, ethyl acetate, for example, what happens here? Alkyl group is added here, alkyl group is added, and what happens here when it is added? It is on hydrolysis, it will give ketones are formed. Okay, and similarly, if you take acid chloride, here instead of ethoxy group, we are having chloride as a leaving group. Okay, methyl is added here, and what happens here when methyl is added? That is again it loses this chlorine easily. As a result, okay, that is MgBr on hydrolysis will give ketones are formed. Okay, generally O minus will be there here also. This O minus is rearranged. Why? Because they are ionic bond. O minus Mg+2 bond is there. It is highly polar bond, and as a result, it rearranges to give ketone. Ketone is formed. Lithium dialkyl cuprate. This is also very important reagent. Dialkyl copper lithium. It is used for alkylation. Just by removing this halogen, we can replace this with the alkyl group. Okay, it is nothing but dialkyl copper lithium. Dialkyl copper lithium. Okay, please respond, students. Are you hearing me? Vinavarthunda?
Yes, sir.
Are you following? Nobody is asking any doubt. Or just on చేసి కూర్చున్నారా? Very important and basics. All these are basics. In intermediate, you have learned all this. Decarboxylation of calcium salts. Okay, we can take calcium salts and convert them into aldehydes or ketone. For example, that is calcium, any carboxylate, when reacted with formate, it is called a calcium formate. Calcium formate, what happens here? It is producing, that is aldehydes are produced. Aldehydes are produced here. If you take only calcium, one of the carboxylate, only ketones are produced. Why? Because in formate, if you take only formate, formate means the derivative of formic acid. If the derivative you will, that is, for example, you take RCOOH, CH3COOH. What will be the? It is called as, what is called as acetic acid. COOH is called as acetic acid. What is the respective calcium salt of this one? It is called a calcium acetate, CH3COO taken twice, COO taken twice, Ca. This is nothing but, what is it called as? It is called as calcium acetate, like this. Calcium formate, formic acid derivative. When distilled at high temperature, automatically you are going to get formaldehyde, like this. Okay, that is depending on the, we can change. Okay, that is, if you take R1, depending on this one, we can convert them into whatever the carboxyl, that is carbonyl compound we can prepare. Depending on the reactants, we can prepare products. Products can be prepared depending on it. See here, if you take hydrogen, both hydrogen, formaldehyde is produced, no byproduct. If you take one of CH3 as a R1, R1 means this one, and R2 means this one. In this reaction, depending on the reactant, product is prepared. One is CH3, another one is hydrogen. One is CH3, CH3. Like this, questions can be asked in a question, in a, that is a, for example, a problem will be there, CH3COOH and HCO, that is HCOO-Na, or calcium formate are distilled. Distillation question, whenever you come across, it is nothing but this calcium salts only, mostly. Okay, what is the mechanism? Calcium succinate. Even we can prepare cyclic carbonyl compounds also, like this. Cyclic carbonyl compounds also can be prepared. Cyclopropanone. Okay, depending calcium adipate, calcium succinate. If you take cyclopropanone is formed. Calcium adipate, if you take cyclopentanone is formed. Another one is oxo process. Yesterday we had seen in alcohols. Alkenes, when reacted with CO plus H2, they are converted into aldehydes. Okay, that is what is the reagent here? COHCO4. It is known as heterogeneous catalysis. Okay, that is what is the reactant? Alkene plus carbon monoxide plus H2. What is the mixture called as? CO plus H2 mixture is called as water gas. Okay, 100% efficiency will be there. Aldehydes are prepared in this manner. Ozonolysis, you are learning about ozonolysis since intermediate stage. What happens in ozonolysis? Here it is the cleaved. This bond is cleaved and this part becomes one aldehyde or carbonyl compound and this becomes another one. Okay, CH3CO, CH3 is one and another one is CH3CHO is another one. Okay, you can break up here also. CHO is formed. Ozonolysis. It is called as ozonolysis. Okay. Then another method is by Stephen's method. SnCl2. First of all, they are reduced. Okay, that is cyanide. Nitriles are reduced and followed by hydrolysis will give aldehyde. Okay, nitriles. How to prepare aldehydes from nitriles? Just now we had seen by using Grignard reagent. You can add either Grignard reagent to this one. For example, you add a Grignard reagent, they are converted into ketones. But if you add a reduction followed by hydrolysis, will give aldehydes only. By Stephen's method, aldehydes are prepared. What is the reagent used here? Reducing agent is metal HCl. SnCl2 plus HCl is used as a reducing agent. Diol H reduction. Just now we had seen what is diol H. Okay, that is converting carboxylic acid into aldehydes. Reduction. Okay, they are not converted into alcohols are not prepared. Only single reduction stage is there. Only one hydrogen will be there. What is the name? Diol means diisobutyl aluminum hydride. Okay, aluminum hydride will be there. Only one hydrogen is used. Generally, lithium aluminum hydride is having how many hydrogens? 4. Therefore, complete reduction takes place. What is the ultimate reduced form of carboxylic acid? Is alcohol. Try to remember, my dear students, core houses synthesis. R should be primary alkyl or aryl. Okay, that is RMGX is giving dialkyl cadmium compound, which reacts with RCOCl to give RCOR. That is again ketone is formed here. Okay, methyl lithium. Lithium compounds, lithium salts are also that is reduced. Methyl lithium and followed by hydrolysis. Methylation takes place here and it is converted into diol, and finally it is that is OH is removed and it is converted into ketone. Dialkyl copper lithium is very important reagent. Wherever you come across halogen, it is replaced by CH3. CH3 ni manamu add cheyochu. Okay, that is about dialkyl copper lithium compound. Walker process is also very important. Oxo process is a heterogeneous catalysis. Walker process is also called as heterogeneous catalysis. Alkene is oxidized to aldehyde. Organopalladium is the intermediate. Okay, organopalladium is the intermediate here. What is the reagent you have to remember is palladium chloride plus chloride, CuCl2. What is the reagent? That is a CuCl2, cupric chloride, PdCl2 and CuCl2 in the presence of oxygen. They are converted into aldehyde. It is also an example of heterogeneous catalysis. Walker process, another one is oxo process. Okay, coming to the reactivity, which is more reactive? Okay, see here. This is nothing but formaldehyde. Formaldehyde is more reactive when compared to other carbonyl compounds. Why? What is the reaction means here? Okay, carbonyl compound is having one carbonyl carbon. It is partially positive charge and oxygen is partially negative charge. Okay, there are 2 hydrogens here. Hydrogens are how many? 2 are there. Okay, that is whichever group, for example, hydrogen and methyl, you compare them, it donates electrons or increases the electron density on carbon. Means it is decreasing the positive charge density. Why? Because it is giving electrons, decreasing the electron donating groups or plus I affecting group decrease the reactivity of carbonyl compound. That is why formaldehyde is more reactive than acetaldehyde, which is more reactive than ketone. In ketone we are having how many? In ketone we are having 2 alkyl groups. What is the property of alkyl group? They increase the electron density and as a result carbonyl carbon positive charge density decreases. As a result, the reactivity decreases. మిథైల్ గ్రూప్ ఏదైతే ఉందో, మిథైల్ సమూహం ఏదైతే ఉందో, కార్బనల్ కార్బన్ పైన ధనావేశ సాంద్రతను తగ్గిస్తుంది. అందుకే చర్యాశీలత తగ్గిపోతుంది. Okay, that is why the reactivity is decreased. Any doubt here, students? ఏది రియాక్టివ్? ఎక్కడైతే ఆల్కైల్ గ్రూప్స్ ఎక్కువ ఉన్నాయో అది లెస్ రియాక్టివ్. ఆల్కైల్ గ్రూప్స్ తక్కువ ఉన్నాయో అది మోర్ రియాక్టివ్. Ketones are not oxidized without CC bond cleavage. Oxidation. మొదటి రియాక్షన్ చూద్దాం. ఆక్సీకరణము అంటాం. Oxidation reaction. Ketones are not oxidized without CC bond cleavage. Acidic potassium dichromate solution can oxidize aldehydes but not ketones. KMnO4 can oxidize ketones also. KMnO4 can oxidize ketones also. These are the ketones. They can oxidize ketones. Okay, very important points you have to remember. Potassium dichromate cannot oxidize, that is acidic medium, ketones. Very important point you have to remember this one. Tollens reagent. Aldehydes are easily oxidized than ketones to carboxylic acids. Tollens, what is Tollens reagent? Ammonical silver nitrate is a Tollens reagent. It is chemoselective. Oxidation does not attack CC double bond. Only carbonyl group is attacked and it is converted into carboxylate ion. Fehling's test. Aldehydes except benzaldehyde reduce Fehling solution. Cu+2 reduced to Cu+. Cupric ion complex with tartarate ion is nothing but Fehling's reagent. Okay, that is tartarate ion. That is cupric ion in the alkaline solution is called as Fehling solution. Okay, remember all this. What is Fehling solution? Only Fehling, Tollens, Benedict, and Schiff. These reagents will give positive test for aldehydes. They will not give any test for ketones. That you have to remember. Benedict solution, copper complex with citrate ion. Just now we have seen copper complex with tartarate ion is called as Fehling's. Citrate ion is called as Benedict. Alkaline KMnO4 also oxidizes aldehydes to carboxylic acids. Okay, that is about Benedict and Tollens, all this we had seen. Then another very important named reaction is Baeyer-Villiger oxidation. What happens here in Baeyer-Villiger oxidation? RCOOR is there. We have to insert one oxygen in between. As a result, RCOR, we compare these two. RCOR is a ketone and it is an ester. What is the difference here? Directly in the presence of, that is peroxybenzoic acid, CO3H. Okay, or otherwise MCPBA. Yesterday also we had seen one of the reaction of this one. That is epoxidation of double bonds are used. This reagent is used. Metachloroperoxybenzoic acid. What is this one? It is called a peroxybenzoic acid. What are we doing? We are inserting one oxygen here. Ikkada oka oxygen nu pedutunnam ante. Okay, it is inserted. Peroxybenzoic acid is converted like this to peroxy. That is it is known as Baeyer-Villiger oxidation. The reactant is this one. Now you get a doubt here. Whereas you will not get any doubt here. Why? Because both are similar carbon. Whereas here you will get a doubt. Now the question is, which is going to migrate among C6H5 and CH3? Which is going to migrate easily? CH3 alkyl groups will migrate easily on. This is because of this alkyl group is migrated. It is electron rich, electron donating. Therefore, it is not going to migrate, whereas this one is going to migrate. Sometimes you will get some other doubt, that is CH3 and C2H5 is there. Among CH3 and C2H5, which will migrate? C2H5 will migrate. You have to understand this one. Let us see that example also. Okay, this is depends on migratory aptitude of all this. Okay, are you getting my point, my dear students? That is CH3. If you take CH3, CO, C2H5, CO, C2H5, C2H5 is there. Okay, what is prepared here? OC2H5 is prepared. Ethyl methyl ketone or 2-oxobutanone. 2-oxobutanone is directly converted into an ester. Ethyl acetate is formed because of the migratory aptitude of this C2H5 is more. Okay, that you have to remember, my dear students. This is known as Baeyer-Villiger oxidation. Just now we had seen about Schiff's reagent. What is formed with aldehydes and ketones? In ketones, no reaction. Whereas Schiff's reagent, para-rosanyl hydrochloride is called as Schiff's reagent. Tollens reagent is reduced to aldehyde, not reduced. Okay. Tollens failing solution is reduced by aldehyde, not reduced here again. Potassium dichromate acidic medium, it is oxidized. Okay, that is iodoform test. Yesterday we had seen iodoform is formed. It is also called as haloform test. Peroxy acid is formed. Peroxy. Whereas ester is formed with ester. Just now we had seen. That is Baeyer-Villiger oxidation. It is called as Baeyer-Villiger oxidation. Here, aldehydes are converted into carboxylic acid. Why? Because we are inserting one oxygen. That is about this reaction. Haloform test. Hypohalite. In haloform test, what is the main reagent that is used? This is also very important question. Many number of times it is asked. Hypohalite, OCl minus or OBr minus, OI minus is the reagent. Terminal methyl groups into acid salt. This group is converted into this chloroform, and the remaining part is converted into carboxylic acid. Okay, base catalyzed. Haloform test. It is catalyzed by in the presence of a base. See, OH minus is there. The mechanism is like this. In the presence of base, what happens? In the presence of base, first of all, one of the hydrogen is removed and anion is formed. This anion again reacts with Cl2 to form alpha chloroacetone, which again another one is removed, another chlorine is added like this continuously. How many are there? 3 hydrogens means 3 chlorines are added like this. 3 halogens are added. These 3 halogens now are easily left over. Many number of reactions we had seen like this, and which abstracts one of the proton, finally giving CHX3. Carbanion ion formation. Okay, first step is carbanion ion formation, nucleophile attack, repetition of step 1, repetition of step 2, like this. Okay, please follow all these. Haloform test is very important. Okay, that is what is formed. For example, if you take iodine for the chlorine, it is called as iodoform is prepared. If you take chlorine, it is called as chloroform. Okay, that is about all these reactions we had seen. Reduction. Aldehydes can be reduced to primary alcohols and ketones to secondary alcohols by catalytic hydrogenation or by the use of lithium aluminum hydride. Okay, the hydride ion in lithium aluminum hydride is very basic, and so lithium aluminum hydride reacts violently with H2O and therefore must be used to dry solvent. Just now we had seen the lithium aluminum hydride. For example, CHO is converted into CH2OH without disturbing the double bond. Double bond is not at all disturbed here. Okay, that is why it is called a regioselective reducing agent. Okay, lithium aluminum hydride, same as Sodium borohydride is same as lithium aluminum hydride, but it can't reduce esters and acid chlorides. Okay, so we had discussed extensively in the last class. Sodium borohydride is less reactive, lithium aluminum hydride is more reactive. Therefore, selectivity is more for sodium borohydride. It can reduce only aldehydes and ketones, but not esters or carboxylic acids are not reduced. Okay. Whereas if you want to reduce even this double bond, metal hydrogenation is used. Okay, we are having ester, we are having primary alcohol, we are having this alcohol. What happens if you use sodium borohydride? Both are reduced. Only two are reduced. Whereas if you use lithium aluminum hydride, all these three are reduced. Esters, everything is reduced. Any oxygen containing carbon is reduced there. And very important reductions are Clemmensen reduction and Wolff-Kishner reduction. Zinc amalgam and HCl is used for Clemmensen reduction. Zinc amalgam and HCl are used for Clemmensen reduction. What happens here? Whenever it is reduced, the carbonyl carbon is removed and it is replaced with H2 directly. H2 directly. It is called as reduction. What type of reduction it is? Clemmensen reduction. If you take zinc amalgam HCl, if you take hydrazine followed by in the presence of base, it is called as Wolff-Kishner reduction. Wolff-Kishner reduction, again same product. Okay, that is both are giving same product. Hydrazine in the presence of base is giving, we are removing this one. If you want to pluck away the oxygen తీసేయాలంటే మనము ఇది reduction, Clemmensen reduction as well as Wolff-Kishner reduction is used. Addition of cyanide. Now, carbonyl compounds undergo another special type of reaction where addition followed by removal of water molecule. Simple addition. What type of addition reaction they undergo? They undergo nucleophilic addition reactions. Cyanide, HCN for example. Cyanide is attacked and it is giving cyanohydrin. It is called as cyanohydrin. Cyanohydrin is formed. Okay, alpha hydroxy carboxylic acid is prepared like this. Kilianin methods. Okay, what happens here? We can increase the chain. How many carbons are there? 1, 2, 3, 4, 5. We can convert them into 6 carbon. What is used here? First of all, we are adding cyanide. We know that cyano compound, it is hydrolyzed and COOH is formed. Finally, what we have to do is we have to convert this one, we have to reduce this one to CH2 is prepared. Sodium amalgam is there. Whenever you reduce with sodium amalgam, HCl or zinc amalgam, it is called as reduction only. CO is converted and finally this CHO, this oxygen is removed here. It is also a reduction process. Sodium bisulfite, hydroxysulfonic acid. Sulfonic acid salt due to nucleophilic attack, sp2 carbon changes to sp3 carbon. This is nothing but sp2 carbon. We are adding sodium bisulfite, NaHSO3. H is added to one and SO3 is added to the other one. Okay, NaSO3, OH. This is also very important reaction. Derivatives of ammonia. You can add ammonia. Okay, derivatives of ammonia means you can add, for example, ammonia is added, NH2 is added to one and hydrogen is added and this is formed. Which on dehydration, water molecule is removed and aldimine is formed or ketimine is formed. Whereas if you take NH2OH, hydroxylamine, NHOH and OH are formed, oxime is formed. C double bond NOH is formed. Whereas if you take like this, you go through, that is addition followed by removal of water molecule. It is called as condensation reaction. It is nothing but condensation reaction here. Okay, that is hydrazine or 2,4 dinitrophenyl hydrazine is also used. Phenyl hydrazine, that is hydrazones are formed. Semicarbazide, semicarbazone is formed. Derivatives of ammonia. Alcohols add to the carbonyl group of aldehydes in the presence of anhydrous acids to yield acetals. Acetal means, for example, ketone is there. It is converted into hemiacetal. In the presence of alcohol, okay, carboxylic acid reacts with alcohols to form esters, whereas carbonyl compounds react with alcohol to form hemiacetal and acetal. Hemiacetal means only one alkoxy group is added. When two alkoxy groups are added, it is called as acetal. What is the use of this one? We can protect this carbonyl. Carbon is protected. Okay, like this. RCHO. Finally, if you want to remove again, just acid hydrolysis will remove this aldehyde. Acetal is stable in the presence of alkali but are converted into aldehyde by acid. Thus, acetal formation may be used to protect the aldehyde against alkaline oxidizing agents. Okay, aldehyde, and it is mercaptol, methyl thiol, that is thioalcohol. Mercaptol, same C2H5OH ఉంటే acetal అనేవాళ్ళం, ఇప్పుడేమో mercaptol అంటున్నాం. Protecting aldehyde can be done like this. Protecting aldehyde, we can also use glycol. Glycol means CH2OH, CH2OH. There are, this carbon is nothing but CH2. Only keto group. Okay, that is here. Aldehydes are protected in this manner by using glycol. Addition of Grignard reagents. Yesterday we had seen the preparation of alcohols. If you take ketones, that is tertiary alcohols are formed. If you take aldehydes, acetaldehyde, primary alcohol, secondary alcohols are formed. If you take formaldehyde, you can prepare primary alcohols. Like this, we can prepare any that is adduct. Aldehydes are converted into 1,2 adduct. That is about. Okay, today's class. Hello students, please try to, that is, go through, revise all the reactions and concentrate. No seat, MSc and chemistry is having great scope. You can flare up to whatever extent. కెమిస్ట్రీ సబ్జెక్ట్లో ఎంఎస్సి చేస్తే మంచి అవకాశాలు వస్తాయి. మీరు ప్రపంచంలో కానీ హైదరాబాద్లో కానీ 100 ఇండస్ట్రీలు ఉన్నాయనుకోండి, 90 ఇండస్ట్రీలు కెమిస్ట్రీ వాళ్ళే ఉంటాయి. కాబట్టి కెమిస్ట్రీకి చాలా భవిష్యత్తు ఉంది. మీరు ఎంత ఎక్కువ కష్టపడితే అంత మంచిది. కష్టం అంటే జస్ట్ రియాక్షన్, కంపారేటివ్ స్టడీ, రియాక్షన్స్ ఏం జరుగుతున్నాయి, రియేజెంట్స్ ఏంటివి. ఆర్గానిక్ కెమిస్ట్రీ అట్లా చదవాలి. ఊరికే చదివితే లాభం లేదు, రాస్తూ ఉండాలి. ఇప్పుడు బేర్ విలిగర్ ఆక్సిడేషన్ ఏం చేంజ్ అవుతుంది, రియాక్టెంట్ చూడాలి, ప్రొడక్ట్ చూడాలి. అక్కడ ఏం చేంజ్ అవుతుంది, ఆ రియేజెంట్ ఏంటిది, ఏం వాడుతున్నారు. మనకు మల్టిపుల్ చాయిస్ క్వశ్చన్స్, ఏం రాయమన్నారు. కాబట్టి మంచి అవకాశం ఉంది. చిన్న ఏజ్లో మీరు రియలైజ్ అయితే కొంచెం కాన్సన్ట్రేట్ చేస్తే మంచి భవిష్యత్తు ఉంటుంది. ఓకే, థ్యాంక్ యూ వన్ అండ్ ఆల్. Remaining, if sir gives the chance, remaining reactions we will see in the next class.
Thank you, sir.
Okay,
Thank
bye.
you, sir.